We now have two Dagger components in our app, with the home component dependent on dependencies provided by the application component. Let's see how these dependencies are used in the generated code. Make sure you've ran a build, and let's start with a quick recap of our application component. Looking at the application component interface, the declaration is pretty empty, only having the factory with the create method. We're passing a context using binds instance to make context part of our dependency graph. That is, objects that are injected by the application component are able to inject context. We aren't using that yet, but we will in future videos. This interface is extending application depths. That has one method returning app repository. We're telling Dagger that our application component needs to be able to provide an app repository. Now let's go into the generated code starting at the factory's create method. This returns the generated implementation of our component, and if we follow it to the constructor, here it just calls initialize. And this is where the dependency providers are hooked up. The mock GitHub API provider is created because it's needed to create an app repository provider. We've seen this all in the last Dagger CodeGen video, so let's move on to the home component where the new changes are. Here we're telling Dagger that this component needs to be able to perform injection on the home fragment class. In the factory's create method, we're passing the declared dependency application depths. Now let's check out the generated code. Again, the factory create method calls the constructor of our component's generated implementation. This calls an initialize method, passing along the application depths parameter. Here we're setting up two providers, one for the app repository, which creates a provider that has been generated to handle retrieving app repository from our application depths interface. And in the overridden get method, it calls application depths.app repository, which is our interface method that returns app repository. The next provider is the home view model provider. This takes in the provider of our app repository, since our home view model injects app repository. These providers are a little different than we saw in the application component because our home component has no scope, like singleton. If there were a scope, these providers would have been wrapped in the same doublecheck.provider call that we saw in the application component. We're going to add a screen scope in the future, so this will change, and we'll come back here to see the effect it had. Next, we have the inject method, where we're saying we need to be able to perform injection on the home fragment. The home fragment injects the app view model factory, and so it needs a provider for that. And if we go to the generated home fragment members injector class, we see that when inject members is called, Dagger simply assigns the fragment field to the value of the provider.get. And this is why these fields can't be private, because Dagger needs to be able to access them. Let's take a break here, and in the next video we're going to go over how multi-bindings work and how that class to view model map is created.